The Performance Tour wouldn't be possible without our wonderful sponsors. So I'd like to thank Tricentis and QA Consultants for your support of the performance engineering community. Thank you. I am on a quest. I want to find out how to make software and hardware perform at their peak. I want to know how to make applications faster, better, and more efficient. And while I'm at it, I want to have a little fun. Don't think I can do it? Just watch me. I'm Scott Moore, and this is the Performance Tour. On the way to Nashville, Tennessee, I went to Charlotte, North Carolina to see my friend Jeremy Prophet of Ally to talk about performance engineering in a serverless environment. As usual, I have lots of questions and concerns about not being able to test and control everything, so I wanted to know what keeps Jeremy up at night. To talk about serverless computing, I've got Jeremy Prophet with me. Jeremy, thanks for being on the show today.
Thank you for having me.
So tell me about you and your experience in IT.
You know, I'm a geek from, before it was cool to be a geek. I remember getting on the internet on a, 9.6K modem and, those days. First one to get kicked off the computers at school, that the epitome of what it meant to be a geek back in the day.
Right.
Went in the Navy, came out, worked at Gateway 2000 for a while, tech support, right? Where we all started.
That's where I started.
Fell into a job at LendingTree, just developing, and one day we had this massive outage, right? It was like everything that could go wrong went wrong. The epitome of one cluster's down all week, and somebody accidentally took down the working cluster for a couple minutes, and you're like, what am I gonna do? And and we find out that a non-prod computer serving prod, obviously, it's like the epitome of the laptop running production.
Right.
The whole thing, and I made this list, right? New CTO comes in, looks at my list, and like, well, that's my notes for the meeting. Takes a picture of it. Next thing you know, I'm SRE. You get to you build the skyscraper, and you're like, now you want to go do it again. Mm-hmm. And so that's what I'm at Ally doing.
Well, I know before you had gotten into deploying large-scale Kubernetes apps, based apps. Is that what you're also doing now, or have you moved to serverless?
Yeah, so we are entirely serverless over at Ally for our division, and that's a pretty amazing place to be. There's no EC2 instances to log into. Obviously we've got a lot of technology at Ally, and yeah, we run a bunch of on-premise data centers. We run in the cloud. There's all these providers out there. We use, pretty much any use case you can find in the industry, you can find it. At Ally. We've been around that long. But yeah, we're serverless, and it is absolutely amazing to just go, hey, I need, and you're done.
That minimizes idle time. It makes the use of the infrastructure more efficient for everybody, because you're basically paying by the drink. However, when I think of that paying by the drink in IT, I think of it versus I've got my own grinder of coffee beans that I pour in there and make myself, which I know is X amount of dollars per pound, versus a K-cup, which is 3 times more expensive. Because aren't we looking at that as the cost?
You're always looking at cost when you're doing anything, especially from a DevOps lens or an SRE lens, and cost matters, right? There are use cases in which I would want to, spin up architecture inside of Fargate versus run it on Lambdas, and there's use cases where I want Lambdas, and there's no way I want to run that inside of a container 24/7, right? So there's definitely use cases there. But having been in IT for so long, there's also the benefits of I will not have to do, if you've ever gone through certifications, or security audits, these things take time. I don't have to provide a security audit for anything in the serverless world. I don't have to tell people how, I don't have to prove to them that my password will expire every 30 days. I don't have to prove to them, all of these things you have to prove when you're running the servers yourself. So that brings inherent value to me.
I see.
Right, so it's a shift, right? So yes, it is more expensive than running it on your own, but on the flip side, if I'm running an import of a data file once a day and it costs me pennies with a Lambda to do, why is that not an advantage too?
Right. I can see that. There's an efficiency that gets you working on more important things that helps you progress a lot further on the app side and things you can see versus the things you can't, the plumbing that you don't want to have to worry about. Now, another thing that bothers me as a performance engineer is poor performant code is a black hole that will suck everything you throw at it. So it seems to me that people working on these serverless apps, the application developers need to be pretty stinking good. I mean, that's got to be a huge priority, right? Otherwise, every time John creates a function, it's 3 times more, costly. I mean, is that something you have to consider?
I mean, performance becomes important when you're running things at scale. And that's when you really need to pay attention to what you're doing. And things as simple as when your code starts up making 4 or 5 different calls to different services to get information, now impact your cold start time of a Lambda or of a container. And yes, those things can impact performance. We have these toolings by most cloud providers that allow us to keep these Lambdas warm. There's other techniques in the industry to do that. And so we can look at that from often DevOps and SRE is looked at to say, okay, help us provide a Band-Aid, right, for this. And we do, right? Sometimes that's what we have to do. Sometimes it's an architecture choice, how we manage certain things. And so, but on the flip side of that, if I'm doing a process every 15 minutes and it takes 2 minutes longer every time, does it really matter, right? So there's times at which performance is important, and there's times when I don't care. Like if I'm running a Lambda once a day to do a little bit of, I've got a Lambda right now that goes to a system and pulls down files.
Right. Maybe it was a batch job in the past or something.
Right, exactly. I don't care if that takes 5 minutes or 10 minutes. I really don't.
Right.
Runs once a day, it's pennies, I don't care.
But when it affects the user experience directly, that's when it's really important.
Yeah, so when you get APIs and stuff that are backend by Lambdas, you really do have to pay attention. And it's not just performant code, it's also, you have databases and, but we add additional layers like, a cache on the API layer or a cache on the database layer. So there's kind of this architecture. There's this book of architecture tricks you can pull to make things performant. And we often do that because it's a couple clicks and everyone's happy, but overall it increases cost. I'd rather see them be more performant, but sometimes getting a product owner to understand that we need to spend 2 more days on code to make it more performant versus clicking a button over here that has an impact of $100, $200 a day forever. If they're like, oh, we'll do this later, right? We'll take the $100 or $200 a day hit over here on the architecture side, and we'll make it less performant here.
At that point, it's a business risk to.
It is, yeah. So it gets into a lot of that too.
So, talk me off the ledge as to why it's not crazy to let somebody else handle the infrastructure for me where I can't control it.
Well, for years we've been allowing other people to manage our infrastructure, whether that's a team that manages patching on your server, whether that's a team that manages security controls and all of that. What we've done with serverless is we've abstracted that security control. We've abstracted the control of the cluster. We've abstracted all of that away to this group of experts at these cloud providers. And all they do is manage this serverless architecture. And if you think about it, what I want is I want people who every single day, their job is to work on this serverless architecture. They've got QA that works on the serverless architecture.
Okay, so I think we both agree that's important, but are we really seeing that in the market? I mean, because it's 2022 and a half now, we still see outages on Black Friday, we still see poor performing apps. Is that a lack of talent, lack of understanding? What is it?
The biggest thing I think we face in the industry right now is that we have a lot of poor performing code out there that was written years ago that we're still trying to leverage. How many major retailers are still running an AS400 in the back room, right? There's a lot.
Is it just a bunch of technical debt we haven't cleaned up yet?
Well, I think it's partly that, and I think partly it's this, Black Friday happens once a year, and if not everybody's happy, then that's okay, because if we went down, did we make our sales numbers? It's kind of this business risk, right? Mm-hmm. And I think too, it costs a lot of money to do the kind of testing you would need to do on a Black Friday. You get caught in these times when they think they're going to have, 100,000 visitors, and all of a sudden it's 5 times that much. Right. And then all of a sudden these databases, which by the way is the bane of our existence nowadays, right? And you can't test them in production, in non-prod very well, because they're like, oh, we're going to do 500,000 hits. I'm like, yes, of the same person. And for goodness sake, can we not vary the data so we can actually see non-cache results in the database layer? Right. I'm like, where are you guys going with this stuff, right? Testing is so difficult at that level, because we often don't use the testing data variance that we really need to. And let's face it, if you're asking for the same client information 500,000 times, at some point you're just pulling from cache.
Yeah, exactly. Yeah, that's part of the performance engineering 101. You've got to make sure that you avoid that. So.
But how many test engineers understand caching structure of database?
Yeah, I think and I've said this many times on the show, is that it's just there's no class you take on performance engineering and IT. You learn how to code, and you get out there and you get caught and you get bit about it, and then you learn the hard way and you avoid it. What are some maybe special considerations that you have to make when you're looking at observability for serverless apps versus traditional ones? Is there something special performance-wise that we should think about?
I mean, it's we have this argument all the time at work where they talk about the teams who are on 24/7 call, and I try to remind them that there's no hard drives to fill up, there's no servers to restart, there's none of the basic did you turn it off and back on again troubleshooting with serverless. Mm-hmm. It doesn't exist. Well, I don't know, you can roll an ECS cluster, but we start monitoring the application a lot more. More important than that, we start monitoring downstream applications a lot more, because when we have problems in serverless, it's either the provider, which by the way, you won't know about until 20 or 30 minutes after the outage starts, right?
Right.
You won't get that communication. Or it's a bug in your code, and let's face it, that's pretty popular. Or it's a downstream application.
Right.
That's the 3 problems we run into nowadays. That's not hard drive. That's not, we're 10% low, we're at the last 10% of the drive. These aren't as measurable. That's where things like APM comes in, not tracing. Tracing is like, oh, this lambda hit this lambda hit this lambda. We're talking about APM, where we actually look at the amount of time it took to make a DynamoDB call, or the amount of time it took to go back to Mongo, grab the record, and come back. So APM has become so much more important, because now I have to monitor third-party applications. Now I have to make sure, hey, am I getting that call from KMS, right? Do I see these containers starting up? And on the flip side of that, the vendors are giving us so much more data via the metrics. I can see, 400 and 500 errors as a numeric value that I can use to say, okay, this is working, this isn't, right? But when your lambdas start going down, the backend and API gateway, all of a sudden I see the spike in 500 errors or the spike in 400 errors. You're like, okay, so we know we've got a problem. It's not communicating with the Lambda. So now we know it's probably an architecture issue, right? And so the troubleshooting is different. The monitoring becomes different. And
so when you're building SLOs, it's not enough to know how well you're doing. You have to know how well everybody else is doing.
Well, and you have to trust that everyone else is monitored.
Right.
One of the biggest things I bring in value when I look at observability is I don't stop with my application. I always put an observability on every one I touch because I can't trust everybody out there to watch their stuff.
Well, thank you so much for being on the program today. This is a lot of good information.
While in Charlotte, I had to check out some of the local barbecue. That included not one, but 2 stops. First, it was City Barbecue. And we also went to 521 Barbecue in Fort Sill, South Carolina. Finally, it was time to head back to my home for 20 years, Nashville, Tennessee, for a road show with James Pulley while enjoying Martin's Barbecue and talking about performance engineering with our friends.
Fix it later was a viable approach in the past, but today, those original premises no longer hold. Fix it later is chaotic, it's old school. We can't do that anymore. The old premises were, we can fix it later because performance problems never happen. And we all know that's true. Hardware is fast and inexpensive now. The cloud has unlimited potential. It's too expensive to build responsive software because we have to spend time on it. We have to pay people to do it. And also, you can always tune it later. Just release it to production now. It's better to get working code because that's what money sounds like, cha-ching, right? Have any of you heard any of that kind of lingo from people in meetings? Does that sound familiar, especially from management?
How many of you believe it?
Well, you know what?
I don't see any hands going up.
That's not an old idea. It was written in 1990 by a book by Connie Smith called Performance Engineering and Software Systems. This is not a new villain we are fighting against, okay? So don't think that you're alone. But this mentality still exists. However, changes will be forced upon us all because the cloud will be the great leveler, and you'll find that out more as we go.
Very rarely do we have a time where our skills and our capabilities are coincident with executive management's desires. And their desires are move to the cloud, cut costs. Costs are directly related to how resources are being used in the cloud. Sparse resource applications are highly efficient. That's what we want. So we now have a time in history, one of the very few, where our specific discipline is highly coincident with executive needs.
How many of you have been hearing about Web3? How many knows what Web3 is? If you do, yell out what you think Web3 is. Is it Bitcoin?
It's the semantic web.
It's crypto. Yeah, we're gonna trade crypto. We see how good that's been. It's NFTs. We're gonna make drawings and sell them for Bitcoin and trade it. Is that Web3? Well, sort of, not really. So how many of you are very familiar with blockchain and how that technology works at all? Or just however. That's really the place that you need to start. So that's the fundamental building blocks of Web3. So let me tell you why this is important for performance engineers. Web 1.0 was, it's really cool that we can get all this crap on the internet for everybody to look at because we got web pages and images of cars and images of stuff, and everybody wants to go check out all this stuff and share information and get online forums. And that was cool. but that didn't really make a lot of money. So the Web 2.0 was to make a richer experience, but now let's start offering services where you become the product, and we will take your information and sell that to marketing companies that will make buku money off your information. And that has rubbed a lot of people the wrong way. Privacy, security. I want to own my own data. If I want to use your platform, that's great. But if you make me mad and I want to take myself out of your platform, I should have the right to remove that because I own my own identity. That's the fundamental premise of Web3, is taking ownership of what you own and your identity and be able to remove it from that and make it distributed enough that you can take it away. So think about, it's the same as Web 2.0. The technology stack is still there. It's still HTML and JavaScript and all the things that you test today. But what happens is that underlying layer are the same fundamental layers as blockchain. Distributed systems that have to have proof of work and proof of ownership to make transactions happen. A ledger that is shared amongst everybody so nobody can cheat, right? And that you have to basically deprecate old versions and everybody agrees to go to the new one. It's cool in a sense, but from an performance engineering standpoint, it's very slow and it's very hard to make that thing speed up. So there's gonna have to be tricks and techniques that they build to make that faster.
How many of you have gone to a web page and found that it has 500 elements on the page and it has 6 megabytes or more associated with the size of the page? That's a lot of activity going back and forth. That's frequency, that's size. So these are really the dimensions of performance. CPU, disk, memory, network, when you allocate, how long you hold on to it, how large it is, and how often you hit it. And if you can minimize those dimensions of performance for all of your resources, you will have a very high performing application. It will be very efficient. 80% of the gains that you can find in performance can be found just in making sure that your application scales for one user. Think of all the decisions you have to make for how you stage resources, how large they are, how efficient the queries must be to the data storage. Bringing all that together, making sure it scales for one. Because if it doesn't scale for one, it sure is not going to scale for many. It may scale for many.
So what that might mean is you might save yourself a whole lot of time when you get that new application that you're going to have to test and it's web-based, and you walk up to the web page and you go, hold on just a second. Let's open this up in Chrome, open up Chrome Dev Tools, open up network, open up performance, run the page. And what was the service level agreement on this page? 5 seconds? Okay, I'm running it. It's 8 seconds. We don't even need to run a test. It doesn't scale. That's performance engineering versus performance testing. I don't need to run a test to tell you suck. Here's what you need. So let's fix that first before we get out of the gate. Send it back to developers to fix that first. When they've done that work, oh, well now, that's what you're checking? Oh, that's Dev Tools. I'm surprised at how many developers do not know about Chrome Dev Tools and the tabs that are available, one of them called Performance.
Let's have playback.